For the circuit, which is going to explain our diode, we have a 100 ohm resistor right here. Off the base, or the termination of that 100 ohm resistor, we've connected a 470 ohm resistor, which is right here. Got some wires. No way, let's move these out of the way so you can see a little bit better. So, come on, yellow, get out of my way. There you go. So we have our 470 ohm resistor right here, and then we have our diode 1N914 right here. For my measurements, I've gone ahead and put some jumpers in here to use for my measurements. I have this yellow jumper off of the top of the diode so I can read across the diode, and the other part of the yellow jumper over here. My power connected from here and then over to the top of this block here, which is connected to the 100 ohm resistor right here. And then I have my ground off this green wire back here, which is connected over to here. When I get to the measuring the current, I'll be going off of this portion to the yellow wire and running it through there instead of having it go straight to ground. We'll get to that when we get to that. Now we're set up. Now that we're set up, we're going to go ahead. Going to our supply, we're going to have it set to 1 volt as it is set inside of our multi-sim. The 1 volt will be turned on as it is right now. And then we will go ahead and go over with our multimeter. We'll read from yellow to yellow, which is across the diode. And we're reading about, we're reading 648 ohms, or volts DC. Going back over to our multi-sim, we will go ahead and press run. Turn off D-sweep first, go back to interactive simulation. And if we run it, we end up with 678 millivolts, which is very close to the score we have down on our voltmeter. Next, we'll go back over to our circuit and keep the negative on the yellow wire. We're going to remove the yellow wire from our circuit. We'll remove the green from our circuit, connect it over to our probe so that we're checking for current. We'll remove our red probe over to amperage, move over to amperage, and on our amperage we're reading 0.02. And then after we've hooked up our probes, we are sitting at 12 milliamps going to ground for the circuit, which if we go back to our multi-sim, see here that we also have 13 milliamps, which is pretty darn close to the 12 milliamps we're holding on to right now. For this portion of the diode current voltage characteristics, our components are going to be a 100 ohm resistor, which we have right here hooked up from pin 6 to pin 7. Then we have a diode that is 1N914 hooked up to pin 7 to ground. We will have op amp AD8542. Furthermore, we're going to have our AD or Analog Discovery 3 hooked up with power plus 5 volts here on pin 4, and then pin for the negative voltage, and then pin 8 will be holding the positive voltage. We're going to have channel 1 positive hooked up to pin in parallel to pin 6, and negative parallel to pin 7. Then we're going to have the check for the diode. We have our blue channel 2 positive on the uh, pin 7, and the uh, part of the diode that is connected to the op amp, and then the other part will be down here connected to the ground, and then we will also have the ground connected to the ground bus for this portion. Going into our wave gen, we will go into custom, and we will set our math script to X from 0 to 1 volts. We'll click normalize so that it goes from 0 to 100%. Then we will have our frequency at 1 hertz. Run for 1 second, repeat once. Next, over to our supplies, we'll put a positive 5 volts and a negative 5 volts on both of these. We'll start by enabling both of these, and then we will go over to our scope to start my last run, so you can kind of see what it looks like when we're done. But our base will be at, for time, will be 200 milliseconds, 1 volt per bit division on both channel 1 and channel 2. We will then turn our scope on, hit wave gen, and then turn the scope off. As we can see, we have on channel 2, which is our diode, we have a slow linear rise until it's over, and then when the power shuts off, it just goes to 0. And then we have an exponential rise coming off of channel 1, which is across the input to the output, or of the AD854 or 8524, which goes up to its maximum voltage, and then when it shuts off, it also goes away.